So it says we've got to display 12 packs of cartons of cola on the base and how many are at the top. So if you guys look at this, you got 1, 2, 3, 4, 5 in the display, 1, 2, 3, 4 in the next row up. So if we have 12 on the bottom, each row has one less, so we would just add these guys up. Now, if I want to do this with the summation notation, we're just basically subtracting 1 between each of the terms or adding 1 between each of the terms. So I could just do 12 over 2. The first row would have 1 box, or the last row, however you want to think about it. And then the bottom row or the last row would have 12. So the sum here should be 6 times 13 to get the total number that we've got in this stack of cola products, which is going to be 78. Alright, can't break this down. The square root of 25 is actually 5, and I can't break this down. So I have negative 1 roots of 3 and 4 roots of 3. So that'll be 3 roots of 3. And then this term right here is just negative 15. So I write minus 15, or you can maybe write negative 15 plus 3 roots of 3. Both of those would be correct. Alright, only way to get your exponent down is swing this over here and put this in logarithmic form. That brings the entire exponent down on the level with the rest of the question. This would be log base 2 of 114. Now, what I would do here is the change of base, because remember, our lovely calculators do not do anything except base 10. I know some of yours do, but most of ours don't. So change of base, changing this to base 10, so I can do this in the calculator. Log of 14 divided by the log of 2. Okay, now I would have to do one more step there, and that would be to take that number and divide it by 5. And it tells me to round to the nearest thousandth, so that's 3 places after the decimal. So this would be 3, 6, and then we'll go up to 7. Very easy to check this problem. 2 to the 5 times 1 point, what was it? 367. And you can hit equals real quick, and it's not exactly because we rounded it, but it's very close to the 114. Okay, this is just a FOIL. Negative 7 times 8 is negative 56. Then negative 7 roots of 2. This one will be negative 8 roots of 2. And then be careful here. This is a negative times a positive. Square root of 2 times square root of 2 becomes the square root of 4. Okay, these guys are like terms, and this is just going to be a negative 2. So in terms of the numbers here, negative 56 minus 2 is negative 58, and then negative 7 roots of 2, negative 8 roots of 2 will be a total of negative 15 roots of 2. Can't simplify it any further because this has a radical and this does not. Okay, isolate here. So the first thing I'm going to do is subtract 7 from both sides. That'll give me 9. Now, the way you want to cancel out the the rational exponent here is to take both sides to the reciprocal power. When you do a power to a power, you multiply the exponents. So if I do 2/3 to the 3 over 2 power, that will just become 1. Okay, now, very important on this question, remember this. I'm going to do bottom out, if you haven't heard of that before. The bottom of the fraction becomes the root. So this would be the square root of 9 to the 3rd. Remember, please, on this question, when you take a square root, you have plus and minus because there's 2 answers. So if you take a 4th root or a square root or a 6th root, there's 2 answers. So because this denominator here is 2, we are taking a square root, and so this should have 2 answers. Okay, square root of 9 is 3, and then to the 3rd power is 27. So you have 2 equations to solve here. 3 minus 2x equals 27, or 3 minus 2x is equal to negative 27. So here I'm going to subtract 3 and divide by negative 2, which will give me negative 12. Now, the other answer, I'm going to do the same action, but this negative 27 minus 3 is negative 30, and then the negatives are actually going to cancel out here. So the other possible answer is going to be 15. And you can plug those back into the original if you want to check. Okay, 5, 10, 20, 40. Looks like the pattern here is that we are multiplying by 2. And then the next three terms, 40 times 2 is 80, 80 times 2 is 160, and 160 times 2 is 320. To solve this equation, you want to isolate the term with the e to the 2x. So the first thing I want to do here, I'm going to move the 5 by subtracting it. And write this over here, 7e to the 2x is equal to 3. Now we're going to divide by 7. So e to the 2x equals 3/7. Now the only way to get our exponent down on the level with the rest of the question is going to be to change this into log form. Now if you guys remember, the base of your exponent becomes the base of the log. I'm going to come all the way over here. 2x, now I'm going to write this and then I'm going to explain it. So it'd be log base e of 3/7. If you guys remember, the log base e can be written as a natural log. That's what the definition of the log base e is. Now, all we have to do, and your natural log button is right here next to the 4 if you've got any kind of a Texas Instrument, we're going to do natural log of 3/7, and then I would end up dividing that by 2, and we are supposed to round to the nearest thousandth, so that is 3 decimal places. So this would be negative 0.424. I would go ahead and round that up. Okay, exponential function y equals ab to the x is the general form you want here. Start with the x coordinate that is larger, which would be this one, and we're going to solve a system. So I'm going to plug in x and y for x and y. So we're going to get 8 equals ab to the 4th. For this question, we'd have 4 equals ab to the 3rd. Now, what you do here is you actually divide. Normally when you solve a system, you add or subtract. If we're working with linear functions, these are exponential. So the reason we're doing this, 8 divided by 4 is 2. A divided by a is 1. So every time on this setup, that would go away. And then we would subtract our exponents here. So this will be b. Once you have that, plug it back into either one of these. I'll just do the one with the smaller exponent. This is 2 to the 3rd here if we know b is 2. So we'd have 4 equals a times 8. Don't write 2. A is going to be 1/2 here. So the answer we're looking for, a b to the x. We solved for b and got 2, plugged it back in, solved for a, and got 1/2. So this is the exponential function that would go through these 2 points. Right in log form, we're just going to swing this down, and the base of your exponent becomes the base of your log. So the little base here is going to become the little subscript here. So this would be 1/4 is the log base 81 of 3. Asymptotes at x equals -8 and y equals 3. We're going to go ahead and keep the 7 on the top. That would not change. So if I have an asymptote at -8, I'm going to do the opposite there. That means -8 is a problem. So this is going to be a +8 in the equation. And then for the y, you just go ahead and copy that. So that's going to be a -3. This would give us asymptotes at x equals -8 here and y equals -3. This one outside here affects the y asymptote or the horizontal asymptote. This one affects your vertical asymptote. Okay, evaluate. This is find the sum, and this is summation notation. And this is arithmetic, and the reason I know that is because I don't have any exponent. You'd have to have an exponent up here for this to be geometric. So this is on your formula sheet. I'm just going to write it real quick. Now, what I need is first the number of terms. So if this starts at 1 and goes up to 6, we're going to have 6 terms. So n is 6. To get the first term, you literally plug 1 into the formula here. So the first term, 3 times 1 is 3, plus 5 is 8. And then the a sub n is the last term, so that's going to be the upper limit. So in this case, it'll be the 6th term. 3 times 6 is 18, plus 5 is 23. So my sum here, my first term is 8, my last term is 23. And then I'm just going to evaluate this real quick. 6 divided by 2 would be 3, and then 8 plus 23. So, oops, sorry guys, not on the screen. So 93 would be the sum. Now, to be honest with you, there's only 6 terms here. You could determine each of the 6 terms using this formula and then add them up. So whatever is faster, they're both valid ways to get the sum. Half-life, and while you guys read the question, I'm going to write the formula real quick. And it says we've got a half-life of 45 days. The initial amount, that's going to be the A, the starting amount. And we want a function that models the decay of the material, how much after 5 days. Okay, so just in general, the function, we have 41 kilograms. The decay rate, or the decay factor, if you will, is a half, because we're going to cut it in half. And then x over the half-life, which is 45 days. Okay, so that would just be the function. If I want to find out how much is left after 5 days, I need to replace x with 5. And you can type the whole thing into your calculator, 41.5, and then I would just put this in parentheses just to be safe, 5 divided by 45, or you could write 1/9, give you the same thing. This is 37.961 to the nearest thousandth. Okay, you can get a real number of a cube root. You can take the cube root of a negative number. This does not have the plus and minus in front of this. The cube root of negative 125 over 343, just taking the cube root of both of these numbers. This has one answer, and it would be negative 5/7. Okay. I'm going to use the power rule real quick. We're going to squish these guys together. So if you have a number out in front, that actually becomes an exponent by whatever follows that. And then if you do have 2 logs with the same base separated by addition, you can further squish those together, and addition turns into multiplication. So this is what we would be looking for here. If we had subtraction between 2 logs with the same base, then that would turn into division as you squish it together. Okay, x and y vary inversely, so this is the k over x, and x is 3 when y is 6. So I'm going to set this up. We've got to find the k value here first. So k is going to be 18, and our general formula here would be 18 over x. And then that's all we have to do apparently. So that's going to be our answer there. Log, cosine, side angle, side. All right, so b squared by itself across from the angle, so it's alone in this big long function for the log cosines. This is on the formula sheet if you guys need it. Doesn't matter the order. You're going to take the 2 sides that surround the angle you know the measure of, and those are going to both be added together and squared. And then 2 times those 2 sides, again, doesn't matter the order, and the 2 is part of the formula, cosine of the angle. Now, you can type this entire thing right into the calculator all in one step. 60 squared, 85 squared. 2 times 60 times 85 times the cosine of 48. Okay, now, the only thing you have to remember is this is equal to b squared. And if you look at that triangle, hopefully you would go, okay, 4,000 is not a reasonable length for that side. But in case, you want to take the square root. I'm going to take this to the 1/2 power, which is the same thing. It's just less buttons for me to push. And we're looking for this to the nearest tenth, so 63.2. Expand the logarithm. So this is working backwards from what we had in number 50, if you look back to that. So I'm multiplying. Okay, when you multiply, you separate with addition. So I'm going to say the log base 9 of 11 plus, okay, now this is a power rule here. So I'm going to write a 5 in front of this log. That will take m to the 5th power if we would squish it back together. So expanded version is going to look like this. Okay, add or subtract. Got to get a common denominator if we're adding or subtracting fractions. Difference of squares here. And if you get the factored form of that, we're in kind of good shape because we already have a w plus 4. So to get a common denominator, all we're going to need is a w minus 4. W minus 4 here. Okay, so the top of this fraction is going to be 6w minus 24. That'll be the first one. Plus 3, all that over the w minus 4, w plus 4, and you could just simplify this a teeny tiny bit. This is going to be 6w minus 21 over w minus 4, w plus 3. Both of these guys are divisible by 3. So you could maybe do that if you wanted to, but that's not going to cancel anything out on the bottom, so I would probably just leave my answer like this. Explicit formula, we're adding 5 every time, so a sub n, a sub 1 plus common difference times n minus 1. Your first term is 3. Each time between the terms here, I'm adding 5. Do not add the 5 and 3 together. You have to do distributive property first in your order of operations. And I'm running out of space, but any term I want, if I combine like terms here, should be 5n, negative 5 and 3 is negative 2. All right, and so if I want the 14th term, then the term number would be 14. So we would plug that in. This is 70 minus 2. So the 14th term, or a sub 14, is going to be 62.